Hi, hello, welcome to my channel. Welcome you back again to study with me. So, here I am with another chapter of great in physics light, reflection, and refraction. Okay, so in this chapter, we'll be studying about light, the processes called as reflection as well as refraction. Okay, so let us start with the intro part. Okay, so what do you mean by light? So we all know what is light, right? So when you look around you, you can see a lot of things, right? So I can see a pen is here with me, I have a notebook with me, so I can see many things around me. So how do I see things? It is because of light. Okay, so we can say that light is a form of energy. Okay, light is a form of energy that causes us the sensation of vision. Okay, that causes us the sensation of vision. So that means light is a form of energy which helps us to see things around us. That is a simple definition of light. Okay, so we know that we have already studied in the lower classes. We have two classification of objects based on the property of light. So they are called as luminous objects and non-luminous objects. Okay, so we have studied these two in the lower classes also, luminous and non-luminous. So let us have an intro about it. So what do you mean by luminous object? So those objects which can transmit their own light, or those objects which emit light by themselves, which emit light by themselves, are called as luminous objects, or those objects which have their own light is called as luminous objects. So example, when we see about a sun is a luminous object. Stars are luminous object because they have their own light. Okay, and what will be non-luminous? So non-luminous objects are those which does not emit light by themselves, which does not emit light by themselves. Okay, so this is what is called as luminous as well as non-luminous. So can you give some examples of non-luminous? Moon is an example of non-luminous object. So some of you might have thought that moon is a luminous object. No, actually moon seems to have some light. So that is because of the reflection of light from the sun. So moon is non-luminous, it does not have a light of its own. And so for example, in a human body is also non-luminous. We don't have any light, right? Except in the films we will see some supernatural characters, they emit light, but in real life it is not possible, right? So this is what is called as luminous object and non-luminous object. So these can be again classify, we can again classify the objects based on different categories. Like first is opaque objects. So opaque object means they have the capacity to transmit, or they allow light to pass through the object completely. Okay, it allows light to transmit light completely. This is called as opaque object. For example, glass is an example of opaque object. Glass is an example of opaque object. Another one is sorry, this is not opaque, this is transparent. Transparent object means what? It transmits lights completely. The another one category is translucent. Translucent means what? It transmits light partially. So that means it allows only partial amount of light to pass through. Okay, so for example, the butter paper. The butter paper is an example of a translucent object. So for example, let me explain what is transparent again. So you take a piece of glass, you look through it. So will you be able to see what is there on the other side? Yes, we can definitely see what is there in the present in the other side, right? So that is what is called as transparent object. That means they allow the light to pass through them completely. Now translucent. So if we have a butter paper with us, okay, so if we look through it, so we know that something is there on the other side, but the image is not clear. What is there on the other side? It is not clear. That means those objects allows only a partial amount of light to pass through them. So that is what is called as translucent. And another one category is called as opaque. So opaque means it does not transmit any light. Opaque does not transmit any light. For example, take a piece of wood. Take a piece of wood or you take a piece of cardboard. Look through it. Can you see what is there on the other side? No, not at all, right? So that is what is called as opaque objects. So opaque objects means they does not allow light to pass through them. Okay, so light is a ray. Okay, light is a ray, and it is not necessary that light needs a medium to travel. For example, we can say that light can travel in air, light can travel in vacuum, or light can travel in water also. Okay, so light does not need any medium to travel. It can travel even in vacuum. So that is a very important point. Okay, so and light is a ray. So what is a ray? Do you know what is a ray? Okay, so for example, you take a single a laser. If we have a single light coming out, then it is called as a ray. Okay, so from the same source, if we have a collection of, or if we have many rays coming out, then it is called as a beam. It is called as a beam of light. So collection of rays is called as a beam. Okay, collection of rays is called as a beam. Okay, fine. So we know what is a ray and what is a beam. So what is beam? Beam means a collection of rays is called as beam. So we have three different types of beam. Okay, the first type is called as parallel beam. That means one ray will be parallel to the another ray. If the rays are parallel to each other, then we call it as it is a parallel beam of light. The next one is called as convergent. Convergent means if all the rays are moving towards a particular point. So if this is a point and if all the rays are moving towards this point, then we will call this as convergent beam. Okay. Similarly, we have another one named beam called as divergent. Divergent means if I am considering this point, if all the rays are moving away from this point, if they are moving away from this point, then it is called as a divergent beam. And if it is moving towards the point, then it is called as a convergent beam. And if the rays are parallel to each other, we will call it as a parallel beam. Okay, so these are the three different types of beams. Okay, so hope this is clear until this. So you know what is light. So we understood what is light, what are luminous objects, what are non-luminous objects, and what do you mean by transparent, translucent and opaque. What is a ray, what is a beam, and what are the types of beams. Okay, fine. So now let us move into the another topic. Let us go detail into it. So what do you mean by reflection? Okay, so reflection means bouncing back of light rays after hitting a surface is called as reflection. Bouncing back of the light rays after hitting a surface is called as reflection. For example, this is a surface. Let this be the mirror. If a light rays falls on this mirror, what happens? It just bounces back. Okay, so if a light rays is falling on this mirror at this point, what happens? It just bounces back. So this process is called as reflection. So we know when we play ball, okay, so ball just bounces back, right? So that is exactly the same process. When light rays falls on any reflecting surface, what happens? It just bounces back. So this is what is called as a reflection. So reflection are of two types. First one is regular reflection. Okay, first one is called as a regular reflection. So regular reflection means a reflection which happens in a smooth surface. The reflection which happens in a smooth surface is called as regular reflection. For example, let us consider a mirror. So we know that the surface of the mirror will be very smooth. Okay, and these be the rays which is falling on the surface of the mirror. And we'll call these rays as the incident ray. That I'll explain you later. So let these be the rays which is falling on the surface of the mirror. So what happens is that in a regular surface, after reaching this point, we know reflection what happens? It bounces back. So from this point, it bounces back. Again from this point, it bounces back. And from this point, it bounces back. Okay. So if you look into these 3 points, we can say that these incident rays are falling parallelly on the surface. Similarly, these reflected rays are also reflected back parallelly, right? These are also reflected. These 3 lines are parallel to each other, right? So this is what is called as regular reflection. Regular reflection means what? The parallel beam gets reflected parallel. The parallel beam of light which falls on the surface will get reflected parallel to each other. So when we say about diffused, or we can also call it as irregular reflection. Okay, when we say about diffused or irregular reflection, where does it happen? It happens on a rough surface. Okay, it happens on rough surface. The surface may not be smooth. Okay, so let us look into the diagram. How does this happen? So let this be a rough surface. Okay, so the lines, the rays which are falling on the surface will be parallel to each other. So the rays are falling on the surface parallel to each other, but the reflection may not be parallel. The reflected rays may not be parallel to each other. So are these three lines parallel to each other? No, right? So this is what is called as irregular reflection or diffused reflection. So regular reflection means a reflection which happens on a smooth surface. For example, the reflection which is happening on the surface of a mirror, or the reflection which is happening on the surface of a marble. So these are all examples of regular reflection. But if the reflection is happening on a rough surface, for example, if the reflection is happening on a road, or if the reflection is happening on a paper, okay, so that is called as irregular. What happens? The parallel beam of light which is falling on the surface of the surface will not reflect parallelly. So this is what are the types of reflection. What is regular reflection and what is irregular reflection? Okay, is it clear? Okay, fine. Now let us deal with the next topic. What is it? Laws of reflection. This laws of reflection is also called as Snell's law of reflection. Okay, because Snell is a scientist who discovered the laws of reflection and refraction. Okay, so before going into the two laws, let me draw the diagram of this one. Okay, so let us consider this as the reflecting surface, or this as the mirror. Okay, so I have an incident ray falling on it. Okay, this is called as the incident ray. The ray which is falling on the surface of the reflecting surface or surface of the mirror is called as the incident ray. So this point is called as the point of incidence. What is it called? I mark it as O, and this is called as the point of incidence. Point of incidence means the point at which the incident ray touches the reflecting surface. Okay. So at this point of incidence, I need to draw a line perpendicular to it. Okay, and this line is called as normal. Okay, so since this is my point, this is the line perpendicular to this point, right? So wherever we are having the point of incidence, at that point I need to draw a line perpendicular to it. That line is called as a normal. Okay, and we know when the light falls on a surface, what happens? It bounces back. So this is called as the reflected ray. Okay, this is called as the reflected ray. Okay, now the angle between this normal ray and the angle of incidence, the angle between the normal and the incident ray is called as angle of incidence, and we'll represent it as theta I. Okay, what is it? Angle between normal and the incident ray is called as angle of incidence, and I'll represent it as theta I. Similarly, the angle between normal and the reflected ray is called as angle of reflection, and I'll represent it as theta R. So theta I is the angle of incidence. Okay, theta I is the angle of incidence, and theta R is the angle of reflection. Theta R is the angle of reflection, and you know this angle is 90 degree because I am drawing the normal perpendicular to the surface. So that will be 90 degree. Okay, I think this diagram is clear to you. So I have an incident ray which is touching at a point O. At this point I need to draw a perpendicular line, and that line is called as normal. And we know reflection means whenever a light ray falls on a surface, it bounces back. So this is the reflected ray. So angle between this normal and the incident ray is called as angle of incidence. I represent it as theta I. And angle between normal and the reflected ray is called as angle of reflection, and I represent it as theta R. Now let us look what are the laws of reflection. So the first law states that the incident ray, the reflected ray and the normal at the point of incidence lies on the same plane. That means this is my incident ray, this is my reflected ray, and this is my normal. Normal at the point of incidence means I am drawing the normal at this point, and I told you that this point is the point of incidence. Okay, don't confuse. This point is the point of incidence. That means where the incident ray touches the reflecting surface. So all these lie on the same plane. That means if I am looking into the reflection which is happening in this paper, then this paper acts as a plane. So the incident ray, the normal and the reflected ray will lie in this paper. So if I am taking air as a medium, so air is the plane. All lies on the same plane. Okay. So this is what is the first law. Second law states that angle of incidence will be equal to angle of reflection. So what does that mean? The angle theta I will always be equal to angle theta R. This angle and this angle will be always equal. Okay, so that are the two laws of reflection. So laws of reflection states that the incident ray, the reflected ray and the normal at the point of incidence lies on the same plane. So this is the first law. And the second law states that the theta, the angle of incidence is always equal to angle of reflection. Okay, so this is law of reflection. This is very important. Okay. Now, I think the concept of reflection is clear to you. How you have to draw the normal, how you have to draw the incident ray, reflected ray, everything is clear. Now, let me ask you a question. So, this is a reflecting surface and this is my incident ray. Okay. So, can you tell me what will be the angle of incidence and reflection? This is my reflecting surface and this is my incident ray. I have marked it very clearly. This is my incident ray. And can you tell me what will be the angle of incidence and reflection? It's a very tricky question but very easy also. Okay, very good. So I think most of you have guessed it. So the thing is, this is my point of incidence, right? So this is my point of incidence. So I need to draw my normal at the point of incidence. The normal should be perpendicular to the point of incidence. So the normal also lies on the same line, right? So this will be my normal. The same line. Normal will also be in the same line because so when I draw like this is my point of incidence and at this point I am drawing a line perpendicular and this acts as a normal. Now since this is my incident ray, this is the point of incidence. So the same line I have to draw the normal, right? So this will be in my normal, perpendicular to the point of incidence. Now, what is angle of incidence? What is angle of incidence? Theta I. Theta I is the angle between normal and the incident ray. What is the angle between these two? Do we have any angle difference? No, because both lie on the same line. So theta I is equal to 0. Theta I is equal to 0. Now, how to find the reflected ray, angle of reflection? So we studied theta I is equal to theta R. Angle of incidence is equal to angle of reflection. So what will be the value? 0. Okay, so this is a very important question. So if the incident ray is falling normal to the reflecting surface, then the angle of incidence and angle of reflection will be equal to 0 always. Okay, if the incident ray is falling perpendicular, to the reflecting surface, then the angle of incidence and angle of reflection will be equal to 0 always in this case. Okay, so hope this concept is clear for you. So we have just covered the introduction part of reflection. So the next video I'll catch you up with the plane mirror, the characteristics and the types of mirror. Okay, till then take care, bye bye.